Welcome back to Chapter 6. We're on to Section 3 on some applications for linear equations. We're going to use some linear equations to solve problems. And we're going to solve a formula for a variable. The second one can be tricky if you're not careful. I'll give you a tip right off the bat. When you're doing this, remember that those extra letters are just numbers. Pretend like they're just numbers because that's what they are. If you do that, you'll be halfway toward being successful on this. Now, how do you solve word problems? Some of these steps, frankly, are a little bit thick. This one, for example, talks about reading it, and then it says let x be one of the quantities in the problem. So you could call this two steps, but we'll go with what the slides say. It's still going to get you to solving word problems. Step 2, write expressions for any other unknown quantities. Remember, you're going to start with x and write down x equals, and then write down whatever you need to. Step 2 says maybe there's something else. Maybe x plus 25 represents something else in your problem. Write all those down. Expressions for any other things aside from x. Then write an equation. Something here, expression there. Solve the equation to answer the problem's question. And last but not least, check and make sure it works, and make sure it's in the original wording of the problem. The equation that you obtained from the words, that's not good enough. You have to go back to the original wording and see if those numbers that you found actually solve the problem. Here's something you might take a screenshot of. Here's some phrases, some words that represent different operations. For example, addition would be represented by the word sum, or more than, because you'll take x plus 25, for example, or increased by would be like x plus 25. Similar things for subtraction, using words like minus, decrease, subtracted, and so on. You can read those. Multiplication, times, product, percent of. Here's the key right here, this word of. That means multiply. Or just straight out multiply by, or twice. That means 2 times something. And division, of course. Divided by, quotient, reciprocal. All those represent phrases that represent division. Here we've got an application indicated by a bar graph. And you can see what it represents. Maybe you want to hit pause and take a look at that. It might be interesting to you. So the question is, the average yearly salary of a man with a bachelor's degree exceeds, that means is more than that of an associate's degree by $25,000. Read through that, pause it, and read through it yourself. I don't have to read it word for word. The important thing here is that it's all based off the associate's degree. So this is what you want to let be your x. And of course, the wording is a little bit better than that. This will be x equals the average yearly salary of a man with an associate's degree. Then you'll get an expression for one with a bachelor's degree and one with a master's degree. And then it says combined the 3 men. In other words, you're going to be adding. If you add their salaries together, you get $214,000. So you've got an addition there. And you want to find the average yearly salary of men with each of these levels of education. So we know something about the salaries, and here's the initial key. Write down what X represents. Write the whole thing out. And also include it's in thousands of dollars, because the X won't be how much the person earns. It's the X in thousands of dollars. Keep that in mind. The other quantities, well, we're talking about the bachelor's degree and the master's degree. So for the bachelor's degree, X plus 25 will represent his average yearly salary, and the X plus 45 will be the yearly salary of a man with a master's degree. I guess I cut part of this off. My apologies. So here's the equation. Okay, the equation here. There's the associate's degree, there's the bachelor's degree, there's the master's degree, and there's the grand total. Now you solve that equation. Just add those all together as we have up here. Combine the x's into 3x. Subtract 70 from both sides. Gives you 3x equals 144. Divide both sides by 3 or multiply by 1/3, and you get x equals 48. Now the importance of this is go back to how you expressed x. What was x? Because x doesn't mean a thing without the context. What does x represent? First of all, it represents money in thousands of dollars. What does X represent? It's the average yearly salary of a person with an associate's degree, and that's $48,000. Don't forget the units, don't forget the thousands. So there's the 48. There's the bachelor's degree person in thousands of dollars. So the master's degree in thousands of dollars. So you got your 3 answers. Check to see if it works. Check it in the wording of the problem. Don't check it in the equation. Check that. Next, we're talking about texting plans. Plan A, Plan B. We want to know how many text messages for when the 2 plans have the same charge. So first of all, we're going to let X represent the number of text messages for that particular number. There aren't any other quantities, just that number of text messages. Write the equation and X models the conditions. For Plan A, here's the expression that tells you what the charge is if you've got Plan A. The $20 and the 5 cents times the number of text messages. Plan B, $5 and 10 cents times each text message. Now what we're working with is, when are these 2 the same price? For how many text messages? Solve the equation. So here we've got the equation we had on the previous slide. Here we'll subtract this 0.5x from both sides, because it's this. In the next one, we'll subtract 5 from both sides. That gives us this equation. And then finally, to get what x is, divide both sides by 0.05. And there you got your answer. That's how many text messages will cost the same in both Plan A and Plan B. Check it in the wording of the problem. There's the cost for Plan A with 300 text messages. For Plan B, 300 text messages, 35 for each, so we're good. We've got the right answer. Next, the computer store is selling digital cameras. Do you have a digital camera? Probably. If nothing else, you might have one on your phone. It says after a 40% reduction, you purchased it for $276. What was the camera's price before the reduction? Okay, how does this work? Go back to the start. There's an original price, 40% is taken off, and you end up paying $276. So let X represent the original price because that's what you're looking for. And write it down. X equals the original price. What are the unknown quantities? Actually, there is another unknown quantity in a way because the X is the original where's my word? X is the original price. What they don't show, and this doesn't mention, is how much is the reduction. The reduction. The reduction is 40%. 40% of the original price. So the reduction is going to be 40%. And remember, of means multiply, so it'll be 40% times the X. So here's the equation. There's the original price X, the reduction 0.4X, or 40% of X, or 0.4X, and this is what you paid after the reduction. Solve this equation, and you get the original price. So here we go. Combine those two X terms, get the 0.6X equals the 276 that you paid, and divide by 0.06, and here is the original price for the camera. Check in the wording of the problem. Remember, not the equation, the actual problem itself. 460, that's what you're saying. Here we go. That's what your original price is. Take off 40% of it. Remember, this of means multiply. So it's 0.4 times 460. And sure enough, you got $276 was your sale price. Now, the trickiest part. Solve a formula for one of the variables. You got a P, an L, and a W. How do you get the L out of that? I'm going to do it just a hair different from what the slide does. Since I'm solving for L, I'm going to take this original equation and I'm going to swap the two sides. So I have 2L plus 2W equals P. Now I want to solve it for L, so I need to subtract 2W from both sides, minus 2W. What do I have so far? I've got 2L equals P minus 2W. Well, that's not quite L. We need to divide both sides by L. Or, excuse me, by 2 to get L. So P minus 2W. Make that more of a W. over 2. And that is the original formula solved for L. Now, what we're going to do is erase the ink, and you can see the way the slide people did it. We're going to isolate the 2L on the right in the original. So to isolate this 2L, we need to subtract the 2W, like this, and of course both sides. This is what you get by subtracting 2W from both sides. And then we'll divide by the 2, and there is the same result that we got previously. Here's another one to try. So we've got T equals D plus PM, and we're going to solve that for P. So here's our original equation. Make sure I've got plenty of room. Now I want to solve for P, so I need to get rid of the D. So T minus D equals, once I subtract the D, I'm left with PM on the right hand side, but I want P, so I'll divide both sides by M. So on the left side I'll have T minus D over M equals, and when I divide that by M, I end up with P. That's exactly what I wanted. P equals T minus D all over M. And that's section 3, folks. You take care of yourself, and I'll see you again in section 4. Bye for now.